So hi guys, so today is day 3 of DSA learning, and let's without wasting time jump into a screen and let me start screen recording. And hope if anyone is watching, just notice one thing: you are the in charge of your success. So don't lose hope and keep grinding. And here, actually, yeah, let me start recording. I don't want to waste your or mine time because time is too precious and we have to utilize it properly. Everyone has a fixed time. ज्ञान की बात sorry, I again speak in English. That's the motto of this high entropy. Okay, let me go and start screen recording. Here we go, and we are at in the website Take You Forward, and here we are solving the DSA problems array. So we covered so far. If you see, we have covered what we covered. Okay, we covered array, not we covered array. Basically we were solving easy problems. Actually I don't think I will be able to complete all the problem until I'll start 2 times a day. So I will start solving it in the morning as well as in the evening. So it's 11 o'clock, more than 11. So it's 11:20. Kai, okay. So we solved till remove duplicates from sorted array. Now we have to find missing numbers. Okay, let's. Oh, they haven't. So it's external problem. It's not the part of practice. Hey, what's wrong with it, man? I think I have to use this. Yeah, got it. I think yeah, it's publicly also they are providing it. So if you are clicking somewhere else, then you are. But if you are a plus member, then they will provide you this problem inside their ID, so we can solve it. It's easy for me, at least. Yeah, I don't have to go to any other website to learn and solve the problem, and I have to also I don't need to log in somewhere else. But I have account in Geeks for Geeks, Lead Code, and all. I think all programmers have. So let's see the problem, and before that, let me clean my rough digital rough. So here we have given an integer array of size and containing distinct values in the range from 0 to n. Okay, inclusive. Okay, return the number missing from the array within this range. Great. Given an integer array of size and containing distinct value in the range 0 to n, inclusive, return the only number missing from the array within this range. So for example, 0, 1, 2, 3, 4, output 5. Nums contain 0, 1, 2, 3, 4, thus leaving 5 as the only missing number in the range 0 to 5. Okay, now next let's see. So total 0. Okay, an array of size n, that means okay, we have n elements and it contains numbers ranging from 0 to n. All are distinct. That means there will be, if there are n numbers, then it will be like 0, 1, 2 up to n. So we have 1 minute. That means the size of array will be 0 to n. Okay, 1 minute. 0 to n means total n plus 1 number. Okay, let me go to this. Okay, what I'll do first, I got the essence of it. Let me note down the example. 0, 2, 3, 1, 4. Okay, great. Let me take one more example. 0, 1, 2, 4, 5, and 6. Okay, great. Now let's jump to this screen. I don't know, I'm not able to If I'll use full screen, it's not like I'm unable to hide it somehow. Maybe I need to check somewhere, maybe chat GPT. I don't know. Okay, so if I'll use something like this, then it will hide. No problem, we'll do this like this only. We do not have any issue with it. Okay, so we have numbers. So they are saying like we have numbers from ranging from 0 to n, all are distinct. So total numbers will be, uh, you can say n plus 1 numbers will be there, out of which n are available and 1 is missing. So we need to find that number. Got it? All are unique. That means, okay, let me think more about it. How we are going to find out the find how are we going to find the missing number? Okay, what I'm thinking, I have one option. We can use mathematical operation here. It is nothing but the sum of all 1 to n, or maybe yeah 0 to n plus 1. It should be n plus 1 into n by 2. Like the sum of number 1 to n is nothing but n into n plus 1 by 2. So here, sorry, this one is wrong because we have 0. 0 is nothing, not going to contribute here in summation. So we can say it will be n into n plus 1 by 2. And then what we can do, uh, we can take the sum of all these numbers, and then what we can do, first we will take sum of all the numbers, and then we are going to what we are expecting the total sum of n plus 1 numbers. So yeah, n plus 1 numbers means n into n plus 1, because here 0 is also included by 2. So if the sum is, and we can subtract this number because always it is will be equal or greater. If it is equal, then we will, that means we are looking for 0. 0 is missing. Got it? That means we have one option to solve it. So let's first solve it using this approach. Okay, what I'm thinking, I remember I think I already solved using this approach, but I need to think more about it. What if I do not have option of it? Then how I'm going to approach it? Then maybe we need to think, can we track all the numbers, whether we found 0, whether we found 1, whether we found 2? No, we can't look. Also, we have an option like, if we have lookup table, then we can say 0, we got it. Okay. Another option, first one we can use mathematical formula. The second one is, we can sort the number and then we can check, sort and check, sort and check. So that one will, so this one is going to take order of n. Okay, my bad, I'm using wrong pencil color, pen color. So yeah, this one. And another option is, sort and check, it will take order of n log n, right? That is the worst case scenario for sorting algorithm. So I learned basics of DSA in the past. That's why I'm able to recall the algorithms. Maybe I need to brush up, but at least I'm able, like, what will be the uh, best or worst time complexity of an algorithm, often sort of a sorting algorithm. So what will be the worst complexity? Worst, sorry. So let me reiterate it. So for sorting algorithms, it can be order of n square. But if we are looking for a best sorting algorithms, then time complexity will be approx, in worst case scenario, order of n log n. So I know it's going to take order of n log n, but if we'll solve it using mathematical operation, using math, then we are going to solve. Just we need to calculate the sum of all the numbers, then we can get the number missing number. So there are two options. I'm not going to use sorting as of now, because these are simple problems. So if we are going to use math, then we can use sum and this. But I'm just thinking, what if we don't have any, we don't have a option to calculate sum, zero. What if I'll take this, number sum? Maybe let me think more. Okay, I have to use timer as well. I forgot it. Let me give it allocated time of 40 minutes. No, 20 minutes. Start now. I'm assuming 10 minutes off for the solving and 10 minutes for this one. So 20 minutes. I'm just expecting I have to use here also. There should be some sort of timer. If you see, I just noticed like here date is incorrect. My bad. Yeah, sorry. So we have numbers like, yeah, we have numbers, like 0, 2, 3, 1, 4. Now I just want to calculate. So we can say we have 0, this, we have 0, okay, we have 2, okay, but how are we going to calculate 0, 2, 3, we found it, 1, we found it, 4, we found it. I don't think we can. So I know, like I can use loop, and if we don't know the formula, then we are going to sum all the numbers and we can calculate it. But again, it's just using the same approach. So what I'm thinking, 0. Also, we need to think more about it. What if we are the sum of all the numbers is too large and we are unable to store it? Then it can happen, right? So in that case, what we are going to do, we will use loop I equals to 0 to n, and every time when we are going to iterate through it, these are nothing but, we can assume these are numbers and these are index as well. So we are going to add this number and we are going to subtract the index number. So in that way, yeah, that will be more efficient approach, but still we are following the same principle. So I'll use this approach instead of solving, first instead of calculating the sum of all the numbers, we are going to iterate and we are going to subtract that number. And yeah, it will be easy for me, not for me, but it will be optimized. We won't get the number overflow or something, some sort of error, because every time we are going to add a number and also we are going to subtract the corresponding number, so we will get negative or positive number, and at then we'll get a result. So for I in range len of nums, okay, if we'll use len of num plus 1, otherwise it's going to use minus 1. So yeah, I mean if we are providing n, then it's going to start from 0 to n minus 1. So we need 0 to n, so we have to add one number so that it will take till size of array, size of list here to be precise. Now we have numbers and let me use cumulative sum is equals to 0, and cs plus equals to, let me say, cs equals to cs minus nums of I. Okay, great. The problem will be here. Okay, I know, I got it. What will be the problem here? Index overflow, or when we will use n plus 1, then definitely it's going to throw error. So let's do one thing. We'll handle the corner case of length of uh, taking the sum of the number, last number, or maybe, okay, let's do one thing. Okay, let me take n as length of nums, and here we what we will do, sum is not, sorry, my bad, sum is nothing but n. So we are already taking care of the last number, so we are taking the sum of it. Now we can iterate peacefully through all the numbers, and here we are taking index because cs minus nums of I, we are just subtracting the number, and we are adding the I. So here basically what we are doing, when we are iterating through array, whatever the index we are getting, for that index we are just plucking out the number. Also we are keep on adding the 0 to n. We are taking the sum of all the numbers, and we are also simultaneously in the same loop we are subtracting the elements of nums array, basically, yeah, list you can say, to be precise. So now finally whatever we will get, that will be the result. We can return cs. So let's see if we are able to solve it. Did I submitted it directly? My bad, my English is too weak. I said if you noticed, if you notice, I said, did I submitted? Did I submit it? Not submitted. Just stay happy. Okay, so we did it. Now I know we need to calculate the complexity. If you see, this is going to take order of n. Okay, order of n, order of 1, order of n. So ultimately order of n. Time complexity will be order of n, and let me see the solution of the past. Yeah, here we did. At least I tried different approach. That's great. We thought about I thought about the corner cases, or I thought about what if number is over. We can't blindly assume like it's the we have a lot of memory and we can store any number. Okay, so here we go. We solved one problem, and now we can exit out of this focus mode. Exit. We solved it. Now let's jump to the another problem, that is find the number that appears once and other number twice. I know this problem. I think we can use XOR operation or something. Some problems I remember because I solved it multiple times. Solved these multiple times. Okay, we are using Python, and here we go. We have a number, single number. I think there is another problem as well. Given an array of nums of n integers, okay, array of nums of n integer. That means the length of array would be n, will be n, not would be. Every integer in the array appears twice. Okay, twice except one integer. Find the number that appeared once in the array. You know, there are multiple options to solve this problem. First, you can use dictionary, and if we are subtracting 1 with 1, 2 with 2, 3 with 3, we don't know. Problem is No, I can't say it. So I know one option is we can use XOR operator. Here, so every number that is equal to uh, there will be pair of same numbers. So both when we will take the jar of both, it will be zero. Right, right, and finally we'll get jar of all the numbers. But what if we don't have that option? Use jar all the numbers array. Okay, here we can see, yes, you can solve using hash map to count the frequency of each number and return time, but also require order of n space. Why is R for this problem? How would you extend this problem if unique number appears k times instead of one? Oh my god. OMG. This is tricky part. Okay, so I think I need to follow up with this problem as well. So let me add a note here. It will be easy for me for in the future. I'll add it later. Let me allocate time of 10 minutes for it because we already know. Just I need to know how we are going to use jar operation here. Okay, as usual, we are going to first solve it using. I know I can directly write it, but still, let me note down the example: 1, 2, 2, 4, 3, 1, 4. So jar of same numbers will be 0. So here first we have 1 to 1 to no, not to. So 1 jar 2 will be some result, jar 2, jar 4, jar 3, jar 1, jar 4. So if you see these numbers, jar is nothing but resulting 0, and these numbers jar nothing but resulting 0, and finally this number and this number's jar will be 0. So finally we got this result. But but what about it? How are we going to take XOR here? Do we have any operation? I mean, do we have any operator to perform XOR operation? X for XOR XOR XOR. Let me call it XOR as XOR, and it will be zero at initially. It will be zero initially. At initially, what the heck? It will be 0 initially, or we are taking 0 at a starting. Now we can start iterating through the numbers. So for I, let me call it as el in. We don't need we know we don't need index, so we can directly iterate through the numbers. And xr xr is nothing but xr xor. I don't know, man, how to take xor. I need to search it. Let me ask here. How to perform XOR in Python. I know there was a symbol directly. Ah, we have a XOR symbol. So my bad. XOR, XOR, EL, and finally return XOR. Okay, here we go. So it's going to take, as you can see, so we are just performing a loop, and now we are going to iterate, and it is iterating through all the elements. So it depends on the length of array, we can say order of n or order of size of a uh, nums array. So finally we solved it as well. These are so simple problems, so that's why. And also I solved in past. I can easily recall this. These are very basic problems. So find a number that appears once and other numbers twice. Union of two sorted arrays. Okay, this one is little interesting problem. I think if you when you will solve, or when you will try to build the merge sort algorithm, when you will implement merge sort algorithm, when you will implement merge sort. Okay, when you will implement merge sort algorithm, then you will have to use this approach to basically, when we have two sorted arrays and we have to club them. uh, it's like we uh, it's like divide and conquer. So first we are dividing, and then we are sorting the uh, basically first we try to divide until we get unique numbers or one numbers both sides. Then we start accumulating them. We will use two sorted arrays, and then we will merge them, and we'll make a single sorted array, and from another side we'll get one sorted array, then we'll merge again. So it's like it's going to, first we are dividing the numbers, then we are sorting and merge clubbing them again. So first divide, then conquer. So here we can't go directly. So let me note down it first. The example in the notebook. So we have two inputs. We will be having two inputs. Let me see the constraints as well. So given two sorted array nums and nums2, nums1, nums2, return an array that contains the union of these two arrays. So we need to return a resultant array. It means we need order of n, or order of length of num plus 2, nums2, nums1 as the array. These elements in the elements in the union must be in ascending order. So both are sorted in ascending order, if you see. Okay, 1 2 3 4 5 1 2 7. And second, the best part here is I need to explain it. And when I'm trying to explain it, then I feel what I have to express it out, and that is challenging part for me. So we have two sorted arrays, and can we say it like ARR1? I like the word variable array as ARR. I use it everywhere. Even I think most of the people use it as ARR, and this now becomes standards. Like for example, if you are using pandas, then we call it as a pandas as a PD, and PD is nothing but pandas representing numpy as NP. So XYZ as a variable. I think these are the variables that has been used so frequently by every programmer. IJ as a loop variable. So, and this becomes common to everyone. No one is going to use Ramesh, Kalu, or something like a variable name. No one, especially. But we should try something like the name of array is Sima, and the name of a loop variable is nothing but donkey, because we use them repeatedly for work purpose. And so can we say like donkey as the variable name of an array, or not an array, but where we are iterating through numbers, and the number, can we call them like maybe students, everyone is going to get marks. Yeah, so we can try multiple options. Yeah, and it's better, but no one is going to use, because it will be awkward and it will be difficult to recognize or what I'm saying. So we have two sorted arrays, and now we need to club them, and the result will be something like ARR, we can say. First, we need to check. So what we are going to do, the process is simple. Start iterating from both the arrays. So we have, let's take one variable I and j. Both are pointing at the starting of arrays. Now we have another variable that will be, or we don't need to variable here because we are going to use Python. So simply we can append an element at the end. Okay, so we can utilize, but normally we need to use something. Now just start with these two numbers, 1 and 1, so we can decide whether we want to take from this one or this one. So we will use same approach everywhere. So let's take, if something is equal in both, then we'll take it from first array. So here, so both are equal. First compare the ARR1 of ith index and greater than equals to AR of 2 of jth index. If both are if equal, take from first array. Great. Okay, sorry, my bad. First array. So we'll store 1. Now second. And if we are taking from the first array, then we have to advance it. So it will be pointing to here, second index. Okay. Now if you can see, this one is larger element. No, sorry, my bad. J will be at the same location. Now we are going to compare this number with ith and jth index of array 2 and ith index of array 1. So again, now the second number is big. So this is one condition. Then we can do I plus equals to I plus plus, else that means if it is not greater than, that means this one is greater than or equals to, yeah. So greater than or equals to, sorry, my bad, one mistake I made. This operator is not going to be this, less than or equals to, then we need to take a smaller number first, right? So here, yeah, so we will take this number first. This number is smaller or equal to this, so we'll consider this one. Else we are going to take from second array. Okay, then we will advance j plus plus. So we'll take out 2, not 2, 1, sorry, my bad, 1 again. Now j will point to this, and again we'll compare both. So we can see I and ith index and jth index are equal. So we can again, as per algorithm, we need to take the first element of array 1, so it will be 2, and we need to advance the index. Now it is pointing to, and index is third index, and it is pointing to a number 3. Now we need to compare 3 and 2. So you can see 2 is the smaller number, so we considered it and advanced the index j to pointing to 7. Now say we'll compare 7 and 3, so 3 will come here and advance the number index ith index. Okay, now we need to compare this 4 and 7, so 4 is going to come here, 4 is smaller than 7. Now we need to compare 5, advance it, 5 and 7, so 5 will come. And if you can see, now we don't have any index here to compare with this, the remaining array elements of array 2. So we can say we already finished all the elements available in the array 1. So now we don't have anything to compare. So whatever leftover is whatever leftover is remaining in any of the array, just we need to append it, and it will be in one only. It will be available in one array only, not in both. Otherwise, we can compare them, right? So we have 7 and we can append it directly. Okay, let me allocate 10 minutes of time. I think that will be enough for it because I already solved this problem, so I know the process. But once we'll move to the medium and hard, then definitely I need to take maybe 1 or 2 hours of duration. It depends on whether whether problem is clicking on my mind, whether I'm able to uh, think about the problem or I need to take help of tutorial and all. So let's first solve this problem. So we have two arrays, nums1, nums2, and here we are going to club both of them, but in a sorted manner. So what we are going to, let's take a resultant array as a list. I'll just take it like this. I'll call this as nums. It will be okay. We have nums1, nums2, and nums. Okay. Shall I start with while loop, or I think while will be perfect here because we don't need to iterate through all the numbers. Okay. Okay. So I will be 0 pointing to 0 and j will be pointing to 0. J is nothing but index of second array, while and n will be the length of first array. So length of nums1 and m will be length of nums2. Nums2. I think I'm using same approach that we while I less than n and j less than m. Then if nums of I is less than or equals to nums of, sorry my bad, not nums of I, nums1 of I is less than nums1 of nums2 of j, simply uh, store the nums dot append what nums1 of I, and we need to advance I plus, here we don't have a plus plus, so we need to use I plus I equals to I plus 1 or shorthand operator I plus equals to 1, and else if we don't have anything, then simply we can do like this. We can do this. We can do like this. Can do nums dot append and nums2 of j and j plus equals to 1. Finally, we have a result array. Return nums. How much time it will take? Okay, sorry, my bad. We just processed uh, we just processed the common element or the elements, number of elements that are you can say minimum length of an array. We just finished one array, but still we have remaining some leftover elements. So while can we say while I less than n, assuming any one array, so one of the loop will going to process it. So while I less than a, nums dot append, okay, nums1 of I and I plus equals to 1. So while j less than m, nums dot append nums of 2 of j, and here we go, j plus plus equals to 1, and finally we got the result, nums array. Okay. Shall I try it now? I think yeah bro, let's try it. I hope I have not made any, oh my god, I did some mistake. Blunder, blunder, blunder. 1 minute. Hold on. What's wrong with it? Union of these two. I did a mistake. You know what? I got it. Actually, I just thought like we are just taking the. That's why I sometimes make mistake and I forget about it. Like I need to take union instead of just merge two sorted arrays. I thought same without uh, seeing the title and all. So I know what needs to be done. We need to uh, t- okay. Let me do one more thing here. So if nums of 1 of I equals to nums of 2 of j, simply what needs to be done, nums dot append, we need to append any one of it. So let's take nums of 1 of I, and we need to advance both I plus equals to 1, because we just want to discard this number I plus equals to 1. But here problem will be one more time. What we have if we have two numbers? Suppose we discarded the both two and we got another number. Mm-hmm. It's a big blunder I did. Let me go back to the. Let me go to the. Oh man, this one I am not expecting good notes. Go back to your safe zone. Go back to. Get back to the safe zone. So let me take an example. We have numbers like 1, 2, 2, and 4. Another array 1, 2, and 5, 6. First, we'll start with these two. So once we got both are equal, that means store it once and discard it, or we can say discard it from another one. Now we got 2 and we are at the 2 second number. So we can say like yeah, both are same. So we'll store 2. My bad. 2 and discard it. Now the main problem exists. Now this 2 will be compared with 5. And here the problem arises. You know what? So for that, what needs to be done? I know this number is going to be placed here, but before inserting it, we need to check the last number. Are you equal to me? If it will say yes, okay, I don't need to be. I think I'm not the right person to sit here. You already took the seat, and I'm equal to you, or maybe I'm equal in hierarchy to you. So we are going to discard. Got it? I got the algorithm, and now we can jump into the code or jump into the screen. So if nums of I equals to nums of j, simply what needs to be done? Nums dot append nums of I plus equals to 1. If nums of 1 of I hmm, nums of I 1 of I, oh man, 10 minutes at a time. Nums of 1 of I is equals uh, greater than hmm, is greater than nums of minus 1, means last index, then append it, otherwise just move forward. And same check we need to apply here as well. If nums of 2 of j is greater than nums of minus 1, then insert it, otherwise discard it. Let me see. I believe I can. Oh man, I did one more mistake here. That means I'm going to do the same again. You know what? I did one more mistake here again. I need to check. So I think I'm doing wrong approach here. Let me do the. I think I'm adding lots of boilerplate code. So if nums of uh, I is nums of 1 of I is less than greater than nums of uh, minus 1, then append it. And same is going to sit here. If nums of 1 of j, my bad, nums of 2 of j is less than greater than nums of minus 1, then append it. I know it's bad approach, but first we need to try it. We need to come up with some approach at least. Okay, my bad, it's not working again still. Mm-hmm. Okay, I know. If we have empty array, so I see lot of boilerplate code I added. Can I create a function? Yeah. Let me create a function. Define this class, right? Append. Append. Why I used so many append? Element and here uh, array self arr and element. So I need to append in the array and element. So if len of arr equals to 0, simply arr dot append element. Else, man, what's wrong with it? Huh? Something is not okay here. Something is not. Someone is not happy. Ah, got it. Something was. Yeah, and the indentation was not working properly. Now it's working. Okay. Else if um mm, 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 array of minus 1 is less than, I think that's not the correct approach. EL is greater than, then only we are going to append arr dot append element. Okay. Wow, great. So now can I say self dot append element and nums of oh resume not exit. Okay. First of all, it will be here. Nums of 1 of I. Huh. And here self dot append element nums and nums of 2 of j, and we can remove this boilerplate code. Okay, and again it's we are doing same approach again. I think still I'm not confident enough to say it is good approach. Nums, but we'll see it. Nums of 2 of bro. There's so much append el nums and nums of 1 of I. Here I made mistake. Ah, sorry. I did lot of mistakes. Did I solve it in past? Yeah, bro. You solved it. No, I don't need tutorial. Hmm. Okay, time is going, and I'm not able to solve it. 1, 2, 3, 4, 5, 1, 2, 7. If both are equal, something went wrong. Means what's wrong with it? We are getting 1 to 7 only. EL greater than array of -1. क्या हो? Oh man, the time is over. I can't take any must. Failed to solve it in the time. Okay, let me see it. I equals to 0, j equals to 0, length of num1, num2, while I less than n, j and less j less than m. If both are equal, then simply append the element at the end of array nums1, I plus equals to 1 and j plus equals to 1. Yeah, true. Both needs to be advanced. Is it the problem of reference or what? Shall I use written? Maybe nums of 1. Oh, sorry, nums. Just wanted to experiment if it is issue of nums. I know that I'm trying to. Ah, mhm. Think when you I'm a little scared, and because of that, okay, it's not the problem of that. First, we are going to get 1, then we are going to get 2, then we need to get 3. But here we are getting 1, 2, 7. Okay, so it is not a problem of 2. I plus both are equal. Advance the number and append nums1 I. Okay, if nums I nums of 1 of I less than nums 2, that means we need to append bro nums of 1 of I. If nums of 2 of j, ah, what mistake I made? One and one are equal. I plus equals to 1. Return array of EL. Let, let's take 1 and 1. I is 1, this one is 1. So both are working. Now we need to check I less than n and m j less than m. Equals to append this one nums of 1 I plus equals to 1 j plus equals to 1. EL if nums of 1 of I is less than nums of 2 of C. That means this one is smaller, both are equal, and here this one is smaller. Then simply append. Yeah, I made one more mistake here. My mistakes are so much. I made so many mistakes. Actually, I need to look into it again. So finally we solved it, but yeah, I let me add note here. You have added so much boilerplate boiler code. What to say? Boiler code and need to check or need to write clean code, and I got stuck in between due to typo mistakes, due to two mistakes I made. Mistakes. Be cautious. Cautious, I don't know if the spelling is Cautious. Cautious next time. So save. Okay. We got it. At least we got it, and that's great thing. And let me solve the final one, and after that I'll maybe in the morning I'll solve medium problems. But yeah, as of now we can say at least we are able to solve these all. Okay, here we solved 7 and we need to solve 12 out of 12. So we'll take time, but we will not lose our momentum and we'll keep on going. So great, here we can say given an array. First let me see the title, to sum. Given an array of integers nums and an integer target, return the indices 0 based index. 0 indexed means index will start from 0 of two elements in nums such that they add up to target. Each input will have exactly one solution, and the same element cannot be used twice. Return the answer answer in increasing order. That means first we need to write the smallest number and then largest number. Given an array of integer nums and an integer target, return all the index of two elements in such, not all the indices. Return the indices 0 index of two elements in nums such that they add up to target. We do not have sorted array first thing, so we can't say like yeah, just start with two pointers and first let's take 1 and 3, and then if both are equal then yeah, if both the sum of both are lesser greater than, that means we have sorted array. So if it is smaller, that means we need to move forward from the left side of array, then we'll get larger number, then the sum will be higher, and if we are getting higher sum, then that means the last number is higher and we need to move backward in the backward direction. So that's not going to help us. So let me first note down the example in our notebook. We have 1, 6, 2, 10 and 3. Let me note down one more example. Example number 2, 1, 3, 5, minus 7, 6 minus 3. So I can see the numbers can be negative or positive, and the range of the numbers can be minus 10 to power 4 to 10 to power 4. So number can be between minus 10 to the power 4 and to 10 to the power 4. And target can be negative to positive 10 to the power 5 to 10 to the power 5 plus positive, and length of number will be 2 or larger than greater than 2. It can be up to 10 raised to power 5. So what I'm thinking, let me think about it. We need index, so we can't sort it. Sort, no. Now suppose we have this number and we are looking for target. How much? 0. Target equals to 0 and target equals to 7. I know one approach would be 1. Now we need to check, can we get 7 from this array? 1. It needs a target minus a array of I, and we need to find it. So every time when we are going to look for a number, for 6 it will be, we got if number, that means we can't expect some number from backside, so we need to look for it in the uh, all the elements that are going to be come forward. 6 means it is looking for 1, so we already got it. But here, if suppose we are not getting, then we need to iterate through all the elements. Here we need 0, 1. Is there any 1 minus 1? No, so it won't work. Let's see power 3. Is there any minus 3? Yes, so we just need to return. So what will be the time complexity for it? So worst case scenario, it could go up to n minus 1th index, n minus 1th number, and it will be 1. So for the first number, it will be n iteration. Second, it will be n minus 1. Ultimately, it will be order of n square. But that is not. And we have nums of length as 10 raised to the power 5. So total will be 10 to the power 10. And that's inefficient. A very inefficient approach. Right. So what is the next option? Can we say it? Do we have any hint, facts, fun facts? Not interested. At least for now. I'm just looking for a solution. Let me read one more time problem if there is any hint. Given an array of integer nums and an integer target, return indices nums such that they add up to target. Each input will have exactly one solution and the same element cannot be used twice. Return the answer in increasing order. Okay, each input will have exactly one solution and the same element cannot be used twice. Okay, I got it. That means same element in the sense same. You can't add like one index of one as element and one as another element. Yeah, got it. How can we make a lookup efficient? We can't use dictionary here. I know order of one will be there hash map for hash map, but still we are solving arrays problem. So I don't think we need to use hash map here as of now. Okay. So what I can do? What can I do here? 16210 16210 we have 1, we have 6, we have 2, we have 10, we have 3. Now I'm just looking for the part composite number or number that is it is not sorted, otherwise we can use binary search. Then n log n will be the time complexity for it, but we can't sort the number because we need to maintain the index of all the numbers. And we need index. That's also the we can't set true or false whether the number is available. Okay. Target return the indices geoindex of two elements in the number such that they add up to target. So if we got a number, that means I thought I'm just sharing you the screen, but now I'm getting nervous. Anyhow, we need to solve it either using tutorial or no. I'm not going to use tutorial as of now. It's not going to help me. I'll forget it again until I'll hustle and solve it. So we can use hint, but let me think more once. Let me think one more time. We have 1, we have 6, we have 2, we have 10, we have 3. Let me take this example 1. That means we are looking for -1. So we are going to how can we say whether -1 is available and what is will be the index of it. So 5 minus 6 7 6 3 minus 3. That means we need to look into the remaining array to find the balanced number. Let me take hint. Hey, they are using dictionary. They are saying like use hash map dictionary to store the indices of elements that. But is it? But but how this hint 2 is applicable here. I'm confused whether this is. Let me see discussion. Someone written solution. It's very unfair, man. These all persons are crying for using hash map. But I thought we have another option. I know I told you like we can use dictionary for lookup. Let me use then D is nothing but, or let me call it as a lookup, and it will be dict of key and value. Value will be index and key will be number. But what if we are looking for a number that great. Still we have challenges. Still, oh god. I'm thinking, let me think. So we'll store like as map it will be 1 will be 0th index, 6 will be at 1th index, 2 will be at 2nd index, 10 will be at 3rd index, and index number at 3 will be at 4th index. So when we are at 1, then look for 6. Yeah, 6 is available. But what if there are more than one element in the array? I believe then we need to iterate through the numbers. Then only we'll be able to solve it. So let me do one thing. Look up dict for I in range create lookup for uh, index of and el in enumerate of nums. Yeah, it's okay. So now if lookup okay, so can I say if el in lookup, I know we can use lookup dot keys, but I think that one will work also without it also going to look for key only, key. So if element in, or maybe if this key is available in lookup table, then simply lookup of key or element will use uh, number to dictionary list append and idx. Okay, else lookup of el dot append, and we are going to append first element, first index. Okay, now it is done. Now let's start with this. Now start iterating, and here for element in elr and index in enumerate, sorry, my bad, enumerate, and nums if lookup so trg means target that we are looking, target minus element. Okay, now we got it. If lookup of el if trg in lookup, simply that means we have a number. So can I say if we have a look available in if target is available in lookup, now we have to check if it is not the same pointing to same index. For I in, so I am taking I in lookup of trg, and if I not equals to idx, then return simply what? Return the idx and idx and what? And one more thing, that will be I. Finally we got it. Let me think about it again. We have list of elements. So first we are going to enumerate through all the, basically we are going to iterate through all the array element, and we are creating lookup. If element in lookup, then simply append index of it. That means we have more than one same kind of number, same more than one element with the same value. Else simply it is first element, then we can append it directly as a list element, and list with a single element, so we can append this list. And now we are starting the lookup for each element. We are going to look for target trg, that is nothing but target minus el, that is the composite number, or maybe you can say opposite number, that the sum of both will be equal to target. If target in lookup means it is available in lookup table, but we need to be a little extra cautious, or we need some sort of filter. So that means it is available, so we need to check in the dictionary or in the list, and we need to find out if I, the index of uh, different element is stored in that particular lookup element, whatever the index having the same key value. So If index not equals to this, then return that index. Okay, one more thing here we need to. So can I say a result is nothing but, and I'll do one more thing here. You know what? I and idx and break. So it will break this loop. And finally, if we got it, mhm. One more problem is here how I'm going to tackle the loops. There are two loops. More biggest big problem. So let me do one thing. Return result dot sort. I'm using so many Python functions, but it's okay. Oh my god, what went wrong? What's wrong with it? Oh. Some Python syntax problem. What's wrong with it? None type object has no attribute. Short. Okay, let me go through it again. We have numbers 1, 6, 2, 10, 3. Target is 7. 1, 6. 1 minute, bro. 1, 6, 2, 10, and 3. So, first thing, we have 1. We'll store in dictionary 1 and corresponding value will be 0. Then go to 6. Corresponding value will be 1. 2 It will be 10. No, 2 will be 0 and 2, and 10 will be 3, and 3 will be 4. So now it will start. We have 1. So yeah, now 1 we have TRG is nothing but target 7 minus and element existing element, that will be TRG will be. First let me print TRG. So oh, one more mistake. I did IDX and EL. I hope now we will be able to solve it. Still, what's wrong with it? Are we getting the error because of it? Hey, but not. Sort in Python. What's wrong? I don't think I will. What the heck, bro? And when I submitted 30 minutes, 32 minutes ago, am I making some? Oh, I'm in the wrong problem, I believe. But, but, something is wrong here. I can see it. I know we are going to use index. So I unordered map I have used. Here I just assumed that. I don't know. Something this. Okay, let me close it now. It's solved, but I'm quite unhappy with it. So for the time being, we can accept it. I'm quite unhappy with Unhappy with the solution that I need to refine refine it. Save. Thanks. Save. And let me close the screen. It's been 12:54. It's around 1 o'clock. Command Shift F5. Not always I'm saying F5, but it's 5. If you can see my face, it's like oily little because I'm not using any. Currently, fan is off, and because of that, and it's little feeling little humid. Uh, what I will say. So for the timing, thank you guys. We are going to rock soon.